Hi, I just wanted to add some clarity to the last video. So I did talk about the boundary of this horn, and I said that it had the form cosine 0 sine, cosine of t 0 sine of t. And I just wanted to briefly comment on that one more time before I go on to do the next example. So the idea where this comes from is we have this equation 4x squared plus y squared plus 4z squared equals 4, and I said that if y equals 0, if we're in the xz plane, if we're on the lip, the boundary of the horn of the ellipsoid, then if that's equal to 0, you're left over with this. Divide all that by 4 and you get this. And this is the equation for a circle in Cartesian coordinates. And if we convert it to polar coordinates, we get this. So that's all that was. Okay, so now let's do another example. So the next problem I would like to do is number 8. So in number 8, we want to go the opposite direction. So we're going to compute the integral over the boundary, or over the curve C of f dot dr. And what is C? Well, C is going to be the boundary of something, right? That's how we use Stokes Theorem. So f, this is going to equal 1 x plus y z xy minus z squared, and C is the boundary of 3x plus 2y plus z equals 1 in the first octant. Okay, so I think it helps if we first draw what's going on. Okay, so if I set x and y to 0, this tells me that z equals 1. So you have 0, 0, 1. If I set y and z to 0, I get x equals 1/3. Okay, so 1/3, 0, 0. And if I set x and z to 0, I see that y is equal to 1/2. So I have 0, 1/2, and 0. So let's see. We have this plane, 3x plus 2y plus c, and I'm going to represent it by drawing that triangle. That triangle is going to represent part of the plane, and I want to only look at the part in the first octant. Well, as I've drawn it, we're only looking at the first octant, right? That's the first octant. And let's just get right into it. So how do I do this calculation? Well, according to Stokes' theorem, this is going to equal the double integral over the surface, right? So let's just review. C is the boundary of this surface in the first octant. So that is literally the blue part. Blue for boundary, I guess you could say. So C is this part right here, right? It's in the first octant, and it's the boundary. Okay, so when I apply Stokes' theorem, I'm going to compute it over this surface S. Well, what is this surface S? Well, the surface S is the actual proper face, the actual face of the object. Okay. So that's going to equal the curl of f dot d dollar sign, and from here I need to actually do the calculation So this is okay, so all I did was rewrite the curl of f like this, right? So this is del x, del y, del z, which is just a, just as a reminder, we can think of the curl of f as nabla cross f, right? So nabla is going to be that row, del x, del y, del z, and f is the third row, right? So it's 1 plus x, 1 comma x plus yz comma xy minus the square root of z. So after a moment, you easily see that you get this, right? So this is that object there after I've computed it, and we're not quite done. So I have this thing here, I don't really like it, so what I can do is I can convert it to the double integral over domain D, and then rewrite this down here, x minus y 1 dot r of x cross r of y dA. Okay, so what is this rx, ry? Well, you have r of x, y equals z equals 1 minus 3x minus 2y. Okay, and how did I get that? Well, that's just this plane solved for z, right? So the plane is 3x plus 2y plus z equals 1, solve for z, and you get this. And then if I compute the partial with respect to x, I get that is a z, and x of yt is going to equal x, y, 1 minus 3x minus 2y, right? Because that's going to be z. Okay, so rx is going to be 1, 0, negative 3. ry is going to be 0, 1, negative 2. And when I compute this using that, I will get 1, 2, 3. Okay, so sorry, 3, 2, 1. Okay, you get 3, 2, 1 dA. Okay, now the thing is, we don't want S anymore, we want D. So what is D? Well, D is this bottom portion on the ground. And so that's going to be when z is equal to 0. So when z is equal to 0, you have 1/3 and 0, and 0 and 1/2. Okay, and if you solve this, you get y equals negative 3/2 x plus 1/2. Okay, so that's just y equals mx plus b. So the interception is b, which is 0, 1/2. So that's why I got the 1/2. And then this is literally just the slope of that line, right? And hopefully you know how to do that, right? Y1 minus y0 divided by x1 minus x0. Okay, so if we go a little further, we can now convert this into actual coordinates. So you get 0 to 1/3, 0 to negative 3/2 x plus 1/2, right? So the outside part is going to be dx, the inside part is going to be dy, and then I'm going to multiply this dot product together, and it should give me 3x minus 5y plus 1. And if you do the calculations, let me do that real quick. Okay, it's going to turn out to be 1/24, but I will show you. So if we rewrite this, okay, 0 to 1/3, 0 to 3/2 x plus 1/2, 3x minus 5y plus 1 dy dx, right? Let me let you see all that, okay? So I'm going to collect the 3x plus 1 because those don't have any y's, and we're integrating first with respect to y. So let me rewrite the outside integral so you get 1/3, and this will be 3x plus 1, right? I integrate and pick up a y, and I'm going to replace it with that, so it's going to be negative 3/2 x plus 1/2, okay, minus 5/2 negative 3/2 x plus 1/2, right? Dx. Okay, so how did I get that? Well, that's the 5y. When you integrate the y, you get 1/2 y squared, right? 1/2 y squared, and then I replace the y with that top part of the integral. Okay. Once I carry this out, I should get the following: negative 3/2 x minus 9/2 x squared plus 1/2 plus 3/2 x minus 5/2 9/4 x squared plus negative 3/4 times 2x plus 1/4 dx. And you might want to pause this for a moment and do it yourself, okay? Okay, so you've now finished and you've got the same thing. Good. Okay, so once you look at it, you'll notice that those terms should cancel. And I'm now going to group everything by powers of x. So I should get negative 9/2 plus negative 45/8 x squared plus 15/4x plus, okay, plus 1/2 minus 5/8 dx. Okay, and then I'm going to do this further. I get 1/3 negative 81/8 x squared plus 15/4x plus, minus 1/8, right? So I'm just combining by the common divisors. And then I can rewrite this as 1/8, 0 to 1/3, negative 81x squared plus 30x minus 1 dx. And this is 1/8 negative 81 over 3 x cubed plus 30 over 2 x squared minus x. X goes from 0 to 1/3. And then in the final bit, we get 1/8 negative 81 plus 15 over 9 minus 1/3. And this is going to equal 1/8. Okay. 1/8 negative 1 plus 5/3 minus 1/3. And I'm going to take that calculation, bring it up to the top, and I get 1/8 negative 3 plus 5 plus 1. Sorry, minus 1. And when I combine all that, I get 1 over 24. Okay, so that is the end of it, and you might want to pause it and look over it. Okay, enjoy.